Hello guys, welcome all of you. Today we have to see Hartley Oscillator, its construction and working. Before we start the lecture, do like, share and subscribe the channel for more and more fresh content. So see, Hartley Oscillator is a type of harmonic oscillator which was invented by Ralph Hartley in 1915. These are the tuned circuit oscillators which are used to produce the waves in the range of frequency which is radio frequency and hence are also referred to as RF oscillators. Its frequency of oscillation is decided by its tank circuit, which has a capacitor connected in parallel with the two serially connected inductors. So see, this is the construction of Hartley oscillator. The Hartley oscillator is similar to Colpitz's oscillator with minor modifications. Instead of using tapped capacitors as we seen in the Colpitz's oscillator, here two inductors L1 and L2 are placed across a common capacitor and the center of inductors is tapped. This is L1 and L2. These are two inductors and which are tapped. The tank circuit is made up of L1, L2 and this capacitor C. So here L1, L2 and C is the feedback network which produces a phase shift of 180 degree. So here our feedback network is L1, L2 and the capacitor which is tank circuit. The resistors R1 and R2 form a voltage divider for providing the base bias and R3 provides stability to the circuit. R3 which is RE provides stability to the circuit. The capacitor CE provides AC ground. The radio frequency coil provides DC load for the collector and also keeps AC currents out of the DC supply VCC. So see the circuit operation. For the circuit operation we can draw the tank circuit. This is capacitor C. This is inductor L1. Inductor L1. Here inductor L2. Here the voltage produced VF, that is feedback voltage, and here it is Vout. So see the circuit operation. When the circuit is switched on, the capacitor is charged. This capacitor is charged. When this circuit is fully charged, it discharges through coils L1 and L2. This discharge setting up oscillations of frequency f. The output voltage of the amplifier appears across L1. This is output voltage appears across L1, and feedback voltage appears across L2. The voltage across L2 is 180 degree. The voltage across L2 is 180 degree out of phase with the L1. The voltage feedback to the transistor provides positive feedback. A phase shift of 180 degree is produced by this feedback network is, see here, this is 180 degree phase shift produced by this tank circuit. Then this 180 degree phase shift fed back to the transistor amplifier, and this transistor amplifier produces another phase shift of 180 degree. So this is 180 degree phase shift produced by transistor amplifier and 180 degree phase shift produced by the feedback network or the tank circuit. So total phase shift is, which is 360 degree. So this is positive feedback. Therefore our condition is achieved, means Barkhausen criteria which is achieved. So see, in this way feedback is properly phased to produce continuous undamped oscillations, and our amplifier acts as an oscillator which is known as Hartley Oscillator. See, this is construction for your reference, construction notes. This is working of Hartley Oscillator for your reference. So see the frequency of oscillation. So frequency of oscillation is f is equals to 1 upon 2 pi under root c into c, 1 upon 2 pi into under root c into LT. LT is tapped inductors. Tapped inductors. C LT, which is write it as LT is equals to L1 plus L2 plus twice M. Here M is the mutual inductance between L1 and L2. M is mutual inductance between L1 and L2. So this is important formula for the problem solving of Hartley oscillator. Then advantages of Hartley oscillator. It may be used as a local oscillator in radio receiver to provide RF output, and second, it is used in high frequency heaters. So these are the construction, working and advantages of Hartley oscillator.